Indian rocket GSLV Mk III weighs several tons more than some of the other expendable rockets in the world, but its carrying capacity is far less, say experts. On June 5, India successfully flight tested its brand new rocket, the 640-ton geosynchronous satellite launch vehicle Mark III, GSLV Mk III, nicknamed Bahubali by the Telugu media and Fat Boy by officials of Indian Space Research Organisation, ISRO. The rocket, powered by its own cryogenic engine at the upper stage, placed communications satellite GSAT-19 weighing 3,136 kilometers or 3.1 ton. The GSLV Mk III rocket weighs 640 ton with a capacity to carry 4-ton satellite. But for instance, Japan's HIIB rocket weighs 531 ton but can place an 8-ton rocket in GTO. Similarly, Soyuz, Russia, 312 ton, payload to GTO 3.2 ton, Falcon, USA, 549 ton, payload to GTO 8.3 ton, and Proton, Russia, 693 ton, payload to GTO 6.3 ton, Long March, China, weight 879 ton, payload to GTO 14 ton, and Ariane 5, Europe, 777 ton, payload 10.9 ton. Sriharikota in Andhra Pradesh is the second best rocket launch site in the world, the expert added. Agreeing that the GSLV Mk III payload to GTO as compared to other rockets is less, Japan, project director, GSLV Mk III, cited a couple of reasons for it. From the rocket's propulsion point of view, in foreign rockets, the lower stages, engines at the lower part of the rocket that are fired first to lift the rocket and make it escape Earth's gravitational force, are powered by semi-cryogenic or cryogenic engines, Apan said. The thrust power of semi-cryogenic or cryogenic engines are higher than that of engines fired with solid fuel. The GSLV Mk III is a 3-stage engine rocket. The core of first stage is fired with solid fuel and its 2 motors by liquid fuel. The second stage is liquid fuel and the third is the cryogenic engine. We use solid fuel in the lower stages as it is cheaper than cryogenic fuel. Even other space agencies are looking to use solid fuel to cut costs, ISRO's Liquid Propulsion Systems Center Director S. Somanath told IANS. But other space agencies are looking at solid fuel to reduce cost only after their rockets carry far much heavier satellites than Indian rockets, the space industry expert pointed out. ISRO officials said the mass of communication satellites is also coming down and hence India may not need a heavy lift rocket. Nearly 55–60% of a satellite's weight consists of its chemical fuel. Now the idea is to shift to electric propulsion of satellites which would reduce their weight, Apan pointed out. Somanath said, ISRO started designing GSLV Mk III with 4-ton carrying capacity when it was making 2-ton satellites. At the global level also the weight of satellites are coming down. It is very difficult to predict the market trends. Electric propulsion will not drastically reduce the weight of satellites to make much of a difference in the rocket's carrying capacity, and it cannot replace chemical fuel. The chemical fuel will be used to take the satellite to its space slot, and for managing it later electric propulsion would be used, the expert said. The Chinese government approved the Long March 5 project sometime mid-2000 to have a rocket with a capacity of 14 ton. The size of communication satellites will have to go up as there is limitation on the orbital slots. It all boils down to planning and also predicting the global trends, the expert added. Citing the example of Japanese HIIB rocket, Apan said the Japanese use lot of composite materials to make the rocket more efficient and lightweight. In future we will also be using more composites in the upper stages instead of metal. Half of the rocket's velocity is achieved only at the upper stage and composite will be the only choice in future, Apan said. The specific impulse of our cryogenic engine is also slightly less than that of others, Somanath added while listing out other reasons for GSLV Mk III's lower carrying capacity. The aluminium used in some foreign rockets are less dense and their weight is less. We will also use such materials to reduce the weight of our cryogenic stage by 500 to 600 kilograms, he said. Simanoff said there are plans to reduce the weight of the electronics by around 150 kilograms so that every kilogram of weight reduced increases the payload capacity. According to him, switching off and restarting of cryogenic stage in the space would also increase the rocket's capacity. Experts said India has to realize its semi-cryogenic stage faster and it cannot have the luxury of spending a decade or more in developing newer rocket technologies. We are planning to realize the semi-cryogenic engine in 2019 and the entire stage by 2021, Simanoff said.